Hi boys and girls, today you will need your 5th grade fractions packet, adding and subtracting fractions. I would like you to turn to page 8 right now, and we are working on completing lesson 4 problem set. Our learning target for today is that we are going to be using these visual models to draw and find common denominators, but we are actually going to step it up a notch, and our answers are going to be fractions that are going to be greater than 1. We are going to rename those into mixed numbers. So just for example, if I have the fraction that's greater than 1 13/12, I can take that fraction that's greater than 1 and I can think, well, what would 1 whole be equal to? And that would be 12 over 12, and that would be equal to 1 whole. And then from 12 up to 13, I have 1 over 12, or 1/12 left over. If I take this fraction greater than 1 and I just rename it using my whole number and that remaining fraction, I'm mixing the whole number with that leftover fraction, and I can rename it as 1 and 1/12. Now, these two things actually mean the exact same thing. So as mathematicians, we need to be fluid. We need to be able to work back and forth between these two forms of our fractional numbers. So that's the main difference that we are going to be working on today. So we are on page 8. We're going to do some problems together, and then you will have some problems to work on your own. As teachers, we have some of the scaffolds written in for you, but you will notice that on problem B and problem C, you will need to do the drawing and partitioning and all of the work on some of those. All right, so as we look at our first problem, I'm going to go kind of fast because this is what we've been working on for a good chunk of the week. So this first fraction is broken vertically into thirds, and then I want to shade 2 out of 3 parts. So I'm just finding a way that I can partition these in an equal way. Okay, this fraction right here is split horizontally in half, and I'm going to shade 1 out of 2 parts. I then am going to take my colored writing tool, and the 2/3 that I have split like this, I'm going to now cut them into 2 parts going this way. And where I have my double shading, that's going to be my new numerator. So 4 out of 1, 2, 3, 4, 5, 6. So 6 should be my denominator. Now, if I look at 1/2 going horizontally, I need to split it into thirds going this way. So I'm just going to make my mark, splitting it into 1, 2, 3 parts going this way. Where that double shading is will be 3 out of 3, 4, 5, 6 parts. Now, when I add across, I am going to get a numerator of 7 and a denominator of 6. So both of these are broken into 6 parts, and I have 7 of them all together. Now, if I were to actually take these over here, if I were to circle this and just move this guy over here, and if I were to circle this and move this guy over here, that would be equal to 1 whole fraction square being made, right? So that would be equal to 1 whole, and then this guy right here is the 1 that I would have left. So 1 with 1 left over, partitioned into 6 parts. So this right here is my fraction that is greater than 1. I'm just going to use some abbreviations. And sorry, my fraction that's greater than 1 is right here. Fraction that is greater than 1. And that is equivalent, or I'm just renaming it using my mixed number. And a mixed number is taking that whole number and then that remaining part. You can also think about this as how many, if I'm making 1, I would need 6 out of 6 to equal 1, plus 1 out of 6 to equal that 7. So all together, if I were to add these, it would be 1 and 1/6. So either way would be okay. All right, now we're going to go ahead and we're going to do this one right now. Looking at this one, we need to do the partitioning. So when we look at that first fraction, we are going to partition it going vertically. So let's take this and partition it into fourths. So I split it in half and then fourths again. And then I want to shade 3 out of 4 parts. And then 2/3, I'm going to split horizontally, going this way. So thirds, I make 2 lines and partition this over. And then I'm going to shade 2 out of 3 parts. So 1 part and 2 parts. Now, with your markers, you are going to do the shading with your colorful tool. So this is broken up into fourths. Now going horizontally, I want to break it up into thirds. And then where that double shading is, that is where you are going to make your new fraction. So 9 out of 12 would be this one. I'm going to switch colors and then going vertically. So this one I'm going to be splitting into fourths. So it's in thirds now. Over here I want to split it into fourths. So then that's going to be half and then split those in half again. All right. And as we look at this fraction, let's go ahead and count the number of partitions that have that kind of double shading that's there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 8 out of 12. I now have these partitioned in equal parts, and now I can go ahead and add all of those parts together. So looking at the equation that is there, 9 plus 8 more, if I were to count all of my check marks, I would have 17 parts that are partitioned into twelfths. Now you can see that this is a fraction that is greater than 1. I only need 12 of these parts to make one whole. So I can think about this, and if it's easier for me to kind of use that visual model to put those parts over here, I could take one of these and move it over here. I could take another one and move it over there, and I could take another one and move it over there. And if I get rid of those 3 parts and just rename them or replace them over here, now I have one whole fraction bar that is complete with how many left over? 1, 2, 3, 4, 5. So my answer is one whole with 5 out of 12 partitions for the next one. So that's one way to think about that. I can also rename this. If I want to build one whole, I could say 12 twelfths plus, let's see here, 12, 13, 14, 15, 16, 17, 5 more twelfths. That's going to get me to the 17 twelfths. So if I think about it that way, my answer would then be one whole plus 5 twelfths left over. So the only difference today is that our answers are going to be fractions that are greater than 1. We are using different models or different thinking to just rename that fraction that is greater than 1 as a mixed number. And know that these two things mean exactly the same thing. So I'm going to have you go ahead and do problems C and D, and then we are going to check those in just a moment. Pause the video, and then we will check these 2 problems in a moment. All right, let's look at problem C. When we first started out, we split it in half, and then this one going horizontally is split into fifths. We shaded 1/2, and then we shaded 3/5 on this side. We then take it and we partition it the other way. So here I needed to split it into fifths going this way, and then when I count those up, I should have had 5 out of 10. And then over here, I had the 3/5. I need to partition that in halves going vertically. And when I do that, I get 3, 4, 5, 6. So 6 tenths. When I add those two fractions together, I am going to get a fraction that is greater than 1, 11 tenths. Now, if I am looking to figure out what my answer would be as a mixed number, I can take these 1, 2, 3, 4, 5. I need 5 of them to fill up this one over here. So I can take, there's 3 right here. If I move those over here, and then I need 2 more, 1, 2 more, 1, 2 more. How much would I have left over then? So I have 1 whole square filled with 1 out of my 10 left over. Another way for me to think about that, if I'm looking at trying to build the whole, 10 tenths would be 1, but I have 11 tenths. So 10 tenths is equal to 1, and if I have 10 plus 1 tenth more, that would get me to 11 tenths. And then if I just combine those, I'm going to have 1 and 1 tenth for my answer. All right, let's look at the next one. All right, looking at letter D, when we shaded 5 out of 7 and then split it in half, our renamed fraction was 10 fourteenths. When we took the 1/2 and then split it into sevenths, our renamed fraction was 7 fourteenths. When we add it across, we should get 17 out of 14, so 17 fourteenths. If I am renaming this fraction that is greater than 1 as a mixed number, I'm looking at this fraction square right here, and it only needs 4 more to complete the whole, to make the whole. So if I were to just move these 4 over here, that would completely fill this up. So then I would have 1 whole square filled up with how many left over? 1, 2, 3 out of 14 partitions. So 1 whole square with 3 out of 14 partitioned. So that's one way to think about it, using that visual model. Also, I can think about, well, it takes 14 fourteenths to build 1 whole, but my target number that I have is 17. So 14 plus 1 number gets me to 17? Oh, 3 out of the 14. And then if I combine these two, I end up with the same number. Okay. Right, now, this is page 9 in your packet, and you are going to be working these problems on your own. If you have some questions about this, be sure to ask your teacher, but you will be working problem 9, just E and F on your own, and then you'll be taking a picture in Seesaw. So today we looked at renaming fractions and adding, but then we also added in one more step where if we get a fraction greater than 1, we practiced renaming that. Great job today, boys and girls.